If you clicked on this video because it was recommended to you on the front page, that's the work of the YouTube algorithm, using machine learning to tell you what you should watch. Let's see how that works. Hello everyone and welcome to a new video. This is Yulia. I make videos about data science and my life in tech, and this series is all about introduction to machine learning. In the previous episode, we've just addressed all things data, so you may want to start there. And today we're going to get into the next phase of a data science and machine learning process, which is of course creating machine learning models. So let's get into that today, and make sure to check out the other videos I have on my channel if you want to get a better idea of how to do data science and data science in the cloud. Let's get into it. So if you've already watched my previous video on data, you already are well off on your journey to becoming a data scientist or understanding how data science works. Now that we have what we need to know about data, it's time to make a model on top of it. Just having data is not as insightful as creating something based on that we didn't know already and we can't get by just looking at a table. That's where machine learning comes in. Let's start off with some context first. I mentioned three buzzwords: data science, machine learning, and artificial intelligence. How do those relate to each other? First off, data science is a field that focuses on studying data and getting insights and information out of various forms of data. It's a pretty broad thing. Then we have machine learning, which is another field of study that focuses on algorithms and statistical models that can predict something or take an action or learn something without being given the specific instruction to do so. And AI is something a little bigger than machine learning that includes an agent learning, maybe through machine learning models, to take an action upon its environment based off what it explores and what it sees from this environment. Now, the relationship between these three is a little foggy depending on what definition you follow. There's a bunch of Venn diagrams that could explain it. There's also stuff like databases and big data and deep learning in there, but these are kind of the same thing with different variations, so we'll just stick with our three buzzwords for now. Now, as I said before in a previous definition, machine learning is the study of algorithms and statistical models that are then being used to perform a task or to achieve a result without having been told specifically how to do that. So learning about its environment using inference and figuring stuff out by itself. So you put a lot of data in, you have this model that processes it and thinks about it and then gives you a result out. And we use this when we don't know how to solve a problem without machine learning. There's problems that we can model quite easily, like say, will I pass this test? And you know that you got a 7 and that the passing grade is 6. Based on that, you can kind of put together that you did indeed pass this test. But let's say we want to predict if you're going to pass a test tomorrow. Obviously, the test hasn't taken place yet, so you don't have the grade that you got, but you still want to predict what's going to happen. So you want to solve this problem without having the specific steps to do so based on some other kind of information. Say, how many hours did you spend studying? What were your results from previous tests in this subject? What your relationship with the teacher is like? How good you are at that particular study. You can use all these other types of data to predict if you're going to pass the test tomorrow. And the prediction can be good or not so good. Maybe you predicted you're going to pass, so you go in without studying so much and you fail. Your model was wrong. Or you interfere with the model in a way that made it not be applicable anymore. There's a lot of information out there that needs to be unpacked, so let's get into machine learning models. To have a machine learning model, we need data, which we've already addressed, and we need a goal. What is it that you're trying to predict? You can't really make a model that's going to solve all the problems in the world. That would kind of be like artificial intelligence. But you can make a model that's very specific to a problem, like predict if I'm going to pass a test, predicts how much a house is going to sell for is a very popular example of that. So we have what is called a hypothesis. I think that I'm going to pass the test or not. I think that this house is going to sell for this much or not. It's kind of like the question you're asking from your data. Some questions can be answered and some cannot. So some models are feasible and some are kind of science fiction. Learning more about data science will kind of tell you how to assess when that is possible and when not. But for the sake of this video, let's assume we're working on a model that does make sense, like predicting house prices. Looking at how much houses are going to sell for, the age-old most popular data science project or question ever. What we do is we start with data that is about houses that sold before. You will have information about your houses, like how many bedrooms it has, how many floors it has, how big is it, how old is it, and how much other houses that are similar to that house sold for before. So you have this table of all these kind of data and you want to train a model on it. Now, if you train a model on houses that have already sold and then you try to predict if your house is going to sell or how much it's going to sell for, then you can have an answer, but then you have no way of knowing if it's right or not, right? Like in the example with the test, until the test actually happens, you don't know if your prediction that you're going to pass is correct or not. So what we do is we pretend that some of the houses that already sold, we don't know how much they went for, even though we actually secretly do. This is called our testing set. Basically, we want to create this model and then predict if a house is going to sell, and we want to have a chance to say if the prediction was good or not. So we need to secretly actually know what the actual answer is without telling that to the model. So a model takes the first 10 houses that have sold for 1 million, 2 million, 3 million, and predicts that a new house will sell for 5 million. Now you actually know that that house sold for 4.5 million. So maybe the model is close enough, maybe it's not close enough. It's up to you to decide what threshold you're comfortable with. You would usually go back and forth through this process in an iterative stage until your model is better and better the more you train it, until it performs almost perfectly on this data that you were using. Then you're ready to send your model off into the real world to try on completely new data that you don't know the answer to. So the house that you want to sell, but obviously haven't sold yet, so you don't know what the price for it is, and you don't know if it will sell today or tomorrow or in a week. You then run this model on this data and it will give you a prediction, and then you can make a decision based on that prediction. Now, what kind of prediction would that be? I already kind of hinted at a few types of examples, but let's fully explore that. There's different types of machine learning model based on what kind of question you ask. So keeping with this example, if I say, I want to know if my house will sell or not, that's a yes or no question. So that's a classification problem. You can classify it as class yes or class no. If I want to predict how much money my house will sell for, so the answer can be a large variety of numbers from $10 to $5 million and everything in between. That's not a lot of different classes. It would take forever to classify all the numbers in between 0 and 5 million. Instead, it's a linear regression problem. So I want to predict the number on that range that this house is going to sell for. Those are a few examples of very common machine learning models, but there's so many models out there. Some are the same type, but different variations. Some are completely different approaches. How do we categorize those? There's three main types of machine learning models out there that most of the models fall under. There's unsupervised, supervised, and reinforcement. Supervised model, which all the models I've mentioned so far are part of, are very common and easy to deal with type of models that are task-driven. So you want to accomplish a task like predicting the price or a yes or no situation of a data, and you have historical data where you have had the answers before. So you can learn from what's already happened and predict what's going to happen next or how it's going to go down. But you have a lot of information about that process. When it comes to unsupervised model, things are not so clearly defined. We use unsupervised models where we want to find out kind of what's happening or what's going on behind our data without knowing so much about the result that we're looking for. The main example of an unsupervised task is a clustering task. So say we have a lot of data entries out there and we want to find different clusters or patterns that fit together. And we may not know exactly why those things fit together. So say we look at all the sold houses before, we can classify them into yes sold and not sold houses, but we know what we're looking for with that classification, right? So that's a supervised technique. When it comes to the unsupervised clustering, we can find clusters of houses that have, 10 houses in this cluster and 5 houses in this cluster and so on. These clusters would tend to behave in the same way, but maybe we as humans don't understand why they were put in the same cluster. If you say beautiful houses, then of course that's something we understand. But the model can just find certain patterns that fit together that aren't completely obvious to the clear eye and just thinks these houses should be treated the same and these other houses should be treated the same. Don't ask me why. You made me to determine this by myself. And then we have reinforcement models, which are similar to both of these other categories, and they are environment driven. Basically, it's something that adjusts to its environment based on slight pushes in the right or wrong direction. Kind of like training a dog. A lot of games are based on reinforcement models. Say you weren't given any instruction on how to play the game, but if you do it correctly, you get a gold star or a higher amount of points, or you progress to the next level. You know, you first start out by doing some random moves to see what happens, and if some of those moves go right, and you know it went right because you progressed in the level, then you're gonna keep doing that move. And then you're gonna try a bunch of things again, and based on the feedback that you get, like, yay, you did it, that's probably positive. Or if you die, that's probably negative. So based on those slight reinforcements, you can find your way to the right result without ever being told how to get there. So you're learning as you go and you're reinforced towards the right direction. And those are the main categories of model. Now there's a lot of other models that fall underneath that, and I haven't mentioned all of them. There's things like decision trees, there's recommender systems, which are the Netflix example that I used in the data video, and so many others. But this is a great start for you to understand the kind of things that are possible and the way that you can look at models or at problems from now on. But that's all we have time for today. Hope you liked this episode of Data Science Basics. Check out the other ones and don't forget to subscribe if you want to see the next ones that are going to come out. If you have a specific request or something you're curious about and would like me to address, please put it down in the comments and I'll get to it. Thanks for watching. Bye.